Welcome to the introductory rundown of our small VEX robotic program that you will be using to work with to construct your own robot and test in the real world using your own code. The basic robot is constructed out of metal parts, and it contains a central control system and several sensors that you can attach to it and use throughout your robot training programs. The most important piece of the system so far is the VexNet Cortex 2.0 system. It has 8 motor ports. No, it actually has 10 motor ports. And each can be plugged into the standard 3-wire pin that enters into the slots, like so. Not like so. Like so, and sits in there along with a special plastic piece that is inserted to keep the wires from coming out. It also has 12 digital ports. The analog values range from 0 to 4095, whereas the digital values are either off or on, meaning they return either 0 or 1. There's also a USB port on the back side of the VEX Cortex, which is used to connect to the computer. This is an A-to-A cable. It has a USB port on each side. So you plug it in here, and then you plug it into your USB on the computer, and this is how you deploy the code to the Cortex to tell the robot what to do. Over here, we have 3 LEDs labeled with different robot, VexNet, and game. When the robot and game lights are lit up green, that means that the robot is on and ready to function. When the game button is green but the robot button is red, it means that the system itself is functionable, but it simply is off. The power switch is right on this side, off or on, simply a switch, and this is the power plug for our 8-volt battery pack. So this is our 7.2 volt, almost 8 volt power pack, and it is inserted directly into the power port here, which allows us to turn on and off the Cortex. Additional ports can be plugged in for a backup battery, which we'll be covering later. The next piece of the robot that's also very important in order for basic movement is the motors. The motors, as you can see here on this model that we have, are attached directly to these gears, which are used for a conversion to the wheel rotations. The motors have a range from 0 to 127. However, when you are coding for a physical robot, it's better to use mid-range values such as 60 or 50 in order to have a more controlled speed. The rotation of a wheel is about 8 inches for one 360-degree rotation. That's about 23.5 centimeters. Attached to our motor is a shaft encoder. A shaft encoder rests on the motor shaft, and as the motor turns the gears on the inside of the wheel, the shaft encoder counts the number of ticks that the wheel turns for. The shaft encoder allows us to travel set distances as opposed to relying on time. The shaft encoder has one on the right side and one on the left side, as you can see here attached to this robot. The quadrature encoder has 360 counts per spin. Just one 360-degree rotation is 360 ticks of the encoder itself. The next portion of the robot that's also vital to the program is the back touch sensor. The back touch sensor plugs into the digital ports because it can only return a 1 or 0 value. When it is pressed, it returns 1. When it remains unpressed, it's 0. Another name for the back touch button is the bumper switch. The back touch is attached to the back of the robot, as you can see on this one, and is used in order to turn the robot on and off without turning the power on and off. in order to allow for certain steps of the robot to be halted and then activated by the press of a button. The motor controllers attached to the back, as you can see here, are what connect the motor communication to the VEX cortex itself and allow directions to pass through the motor controllers and direct whether the motor should be spinning forwards, backwards, or which one should be on or off at that time. These wires that connect all of the materials on our robot, as you can see here, are simple 3-pin wires. Most have a plastic tip like this, which inserts conveniently into the ports that we have on our VEX IQ Cortex, and also between each other with certain connectors. On the front of our robot, on this claw here, we have one motor here to open the claw forward and backwards, and another motor on the side here that controls the arm movement up and down. At the front of the claw, we have a touch sensor that also returns digital values 1 or 0. The limit switch can be attached to the front here and is used to sense objects when they touch the inside of the claw. An important piece when deploying programs to your robot is the LCD screen, which allows you to project the commands that your robot is doing onto the LCD screen that you have. There is 2 lines, each of 16-digit spaces, and can be used to project both strings, which are words, or number values. These 3 buttons allow programmable commands, such as viewing the display of one sensor or another, or simply shutting off the LCD screen. This is very useful in order to control what your robot is doing at the moment and what values it is returning, and it is called the LCD module. On the front of the robot, we have another very important sensor, which is the sonar sensor. The sonar sensor is a ultrasonic rangefinder and uses echolocation in order to send out a certain clicking sound perceivable to the human ear until it reaches an object in front of it. The clicking sound then comes back to the sensor, and the sensor uses the amount of time that the click traveled for in order to calculate the distance that it is away from an object. The ultrasonic rangefinder works from values of 6, I believe, to 250. So anywhere between that centimeter value is good for the ultrasonic rangefinder to see. Another piece on the robot are the line followers. The line followers are infrared lights that shine off of the surface beneath them to determine whether it is a light-colored or a dark-colored surface. The line trackers themselves, there's 3 of them, one left, right, and center also. Each of the line trackers can be used to follow a straight or wobbly line. When it is a dark line, the threshold that is used to program them is high, and when it is a light area, the threshold is low. The line tracker differentiates between the different surfaces using an infrared light, which is a type of electromagnetic wave, sending out a small electromagnetic wave and seeing how frequently the light bounces back. The way the arm movement of the robot works is through the potentiometer, which is attached to the robot here and plugged into one of the analog ports because it has a value of up to 4095, and it looks like this, but it is separate from the robot with a shaft being inserted into the center hole. The potentiometer has a range movement and is best mounted on a 45-degree angle in order to allow the most fluid movement of the arm and prevent the breakage of the potentiometer. If the potentiometer is mounted on the wrong way, it can easily break both the robot and the potentiometer itself. A potentiometer is a variable resistor easily found in things such as light switches around your house. The gyro sensor is a small piece that is mounted on the front of your robot, which is very delicate, and the pins are very easy to break, so should be handled very carefully. The gyro sensor itself has a small light on the front, right here next to the initials PWR, which turns green when the robot is on. This small green light indicates that there is proper power to the gyro and it is functioning. The gyroscope contains a small crystal suspended in a viscous liquid, and as the robot turns, the liquid recognizes how much the robot has turned, allowing it to measure 90-degree turns, 180-degree turns, 270, or even a complete revolution. However, the gyro sensor needs to be reset and allowed to stabilize for 2 to 5 seconds in order to completely clear it every time you use it in your code. The B next to the 3 wires indicates which side the black wire should be closest to when it's used to connect to the VEX IQ Cortex. The LED, there is a small LED light attached to our robot here. It is red in color, and it is used to indicate whether the robot is turned on or turned off, which we can demonstrate by plugging in this battery. As you can see, the lights have turned green on the top, and when I turn on the robot, the LED flickers until it has been indicated to turn on. The LED light can be used to indicate that an object has been detected by the sonar sensor, when the robot has completed its mission and has stopped, or when the limit switch is pressed or the back touch is also activated.